Today we're going to be talking about Chapter 5, Control Structures Part 1. So today's lesson we're going to go on talk about some very basic syntax of C Sharp. A lot of the syntax should look very familiar to you from your C++ or Java classes. It's just one of those lectures that we kind of just got to get through the basics of the syntax of C Sharp so that we can move on to bigger and better things. So the first new concept we want to talk about is the idea called region tags. And so I use lots of region tags in my code all the time. And it's just a way to format your code and make it more readable and just structures a little bit better. So what we can do with a region tag is we can say pound region, and then we name the region. So for instance, I always use an attributes region, and then we end the region. We can see the IntelliSense pops up. What's nice about adding these regions is you can see it collapses down your code. So then I can come in here, and say private string s name, for instance. And again, imagine you had 50 of these attributes, and now I can close it down something like this. Another region tag that I always do is one called methods. So I'll do something to this nature, and then I'll actually just go to the end of all my methods, do pound end region, and you can see that now I've got my two regions, my attributes, my methods, and on top of that, what you can even do is even add subregions. So maybe you've got a pound region, these are detailed methods for the database, something to that nature. And so now you can see I've got a region within a region. So, okay, so here's all my general methods. Oh, here's a subsection for all my detailed methods that access the database, something to that nature. So you can see what's nice about this. I just open up the code like this, and it's very easy to jump the attributes or methods or even subsections within the attributes. Now, again, it's hard to figure out exactly what all the shortcut keys are, and it takes a little bit to memorize them, but I promise you that if you come in here to the edit menu and you go into advanced, there's all kinds of shortcut keys here that you'll find that are really helpful. Like if you want to format the document, like it seems like a tab's just not quite working correctly, you can go ahead and format the document. Or again, you could come in here and just click format document. So if something was off, you could go edit advanced format document. You can see how that pops back into place. So other things we can do is, you can format the selection, but one that I use a lot is what's called outlining. And so what you'll notice is that there's one here called collapsed definitions, where you do Control plus M and then press O, all while holding down the control character. And so what that does is that actually collapses all of your definitions down. So again, if I hold down Control then press MO, you can see it collapses them all down. And this is actually how I grade your programs, is I walk right in to your program and I just do Control MO, then I open up attributes and I kind of look through those, make sure you have comments, things are named appropriately, close that down, open up methods. And it's nice because each method is closed down, and then I can just start looking through them. The same thing if you're maintaining someone else's code. This is an easy way you collapse it all down, then you can navigate to the regions you want and then expand it. Now what you can also do with the outlining is you can do toggle outlining. So you can see that's a way that I can now open them all back up. So sometimes, I just want to, for instance, I'm trying to solve an error for you. I may do that, just open it all up so I can take a look at all of your code within all of your regions. So that's what the region tags are used for. I use them all the place in every single class I use, and I'd recommend doing that in your assignments also. It just helps structure your code and make finding things so much easy. So the next concept I want to talk about is something called pseudocode. And this is just really the idea of designing out your programs before you get into them. In the real world, you'd be shocked at how much paperwork you have to do before you even write a single line of code. For instance, one project I was on, this particular project, the entire length was 6 years, the whole software project. And so what that 6 years of writing an application really means is that you do about a year of requirements, around 3 years of designs, and during the design phase there's also a test team writing tests for the future code and how they're going to test things, and getting their heads wrapped around the database and the code and things like that, what you're going to code. Then there's a actual coding phase after all this design, and that was only like a year long. And then after that there was another year or two of just pure testing. There's about a year of testing. So a 6-year program, a year of it was actually writing any code at all, just to give you an example of what you could possibly look at. And again, this particular customer we were dealing with was the Air Force, and they need an insane amount of documentation and proof that you're thinking through the problem, and they actually care about all your UML designs and all of this stuff up front, because we're dealing with a very serious system. Where if you were just writing a program for a mom and pop shop, where $10,000 is a lot of money to them, that's they're not going to care about seeing UML diagrams and designs, right? They just want that end product. Where someone like the government, when we're writing their programs dealing with missiles, we blow through $10,000 a day. I mean, that's just the reality when you have these 20, 30 people working on a particular project. So the idea of pseudocode or writing your designs just helps you get your head wrapped around the problem. Now in this class, I'm not going to make you write a whole bunch of UML designs. These programs just aren't complicated enough, but just know in the real world you're going to have to do that. And it can be quite useful. It all depends on the complexity of the project you're dealing with. So what you really do during the design phase is you sit down, take a look at the problem, and you start breaking it down into smaller, more manageable chunks. And you start thinking about, how you can abstract out the code, divide up the work, some helpful classes and controls. So for instance, if you have a reporting system, maybe you have 5 developers and you have 20 different reports you're going to write during the length of your program. And so maybe there's one user interface and then the user clicks on a particular report and they can run it. So you need to figure out, which developers are going to write which reports. And maybe there's, for instance, only a single way that you would enter in like a date range on all the reports. So maybe you could have one person write the code for how the user is going to enter dates, how it's going to look, how they validate all that, and then this one person writes it, and then all 5 developers use that on all of their particular reports they're writing. So then you divide up the reports. And let's say you get assigned 3 reports, and that's your job, is to design and write the code for these 3 reports. So what you do then is you would sit down and you say, okay, I'm looking at this first report as ABC and it's financial information, something like that. You're trending some sort of finances over a year. And so now you sit down and you think to yourself, okay, so here's my requirements for my particular report. What kind of classes am I going to need? How is my code going to be structured? Then you identify the high areas of risk within your program. So those you can actually start writing some prototypes, because you want to do is you want to reduce the risk by proving out certain concepts. So hey, can I connect to my database and pull back enough data fast enough? Is my UI responsive enough? They're very complex financial algorithms that you need to get your head wrapped around. I mean, you're a software engineer, right? You're not an accountant. And so maybe you need to figure out these algorithms, work with an accountant or whatever, and figure out how to correctly implement them in code. Because maybe they can write out some formulas, but translating a formula into code might be a whole nother ball game. So now how does that apply to this class? Well, I have seen time and time again that the students who take this advice that I'm about to give you always produce better programs. They're able to do them faster with less bugs, and the code is much more readable on my end, and they're always getting better grades. I absolutely promise you, if you listen to me on this next part, you will do better in this class and become a better programmer. And that is simply thinking through the problem of your assignments before you just sit down and panic and just start coding. Because what inevitably is going to happen is that students wait till the last minute and they've got, it's due the next day, and they just dive right in and just code, 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 code. And this inevitably, you write sloppy code, it's messy, it's not well structured, it's going to be buggy, and I promise you it'll actually take you longer doing it this way than if you just sit down for 10 minutes and think through the problem. And so one way you can do that is just kind of pseudo-code it out. So you come in here and there's a tic-tac-toe program, for instance. So you would sit down and you think, okay, what are the rules for tic-tac-toe? What are the requirements for the assignment? Well, okay, what kind of classes am I going to need? What kind of methods am I going to need? So you'd come in here, you'd say, okay, I know I'm going to need a class, so that's going to have the business rules in it for tic-tac-toe. So I would come in, and again, you're just pseudo-coding it out. You're not actually going to write a lot of code. You're just going to say, I'm going to need a CLS, tic-tac-toe. You start this up and you think to yourself, okay, so again, we're just thinking through the problem. I know I'm going to have some sort of, array that's part of the assignment. It's an integer array. Again, don't worry about the syntax, and you can actually write the code. Or another way that you can do it is you could, for instance, just write a comment in here and just say, I need an array to hold the game board. And then maybe I'm going to need a method that says is winning move. And now again, it's not going to work. There's no code. I'm just sort of writing just the stubs of the code. Maybe I'm also going to need some helper with things that says like, is there a diagonal win, for instance, and et cetera, et cetera. So you sort of just stub out the attributes you're going to need, you stub out the methods, kind of put some more comments for some other methods you may need, maybe write some of the requirements, some really complex requirements that you don't want to forget about right within your code. Then you come back to the form here and you kind of do the same thing and you design out your UI. And you come here and you drag and drop and you make your UI. Again, that helps you get your head wrapped around the problem. Then you think to yourself, okay, well, I'm going to need a button click for this label. I'm going to need a box for statistics. Oh, statistics, okay. So then I come over here to my attributes. I'm going to need a game player name. I'm going to have a private I win. Whoops, private, int I num wins. So how many wins there are, how many losses, how many ties. And all you're doing is stubbing out the code, and you'll do the same thing, just kind of stub out some methods. And what that's going to do is help you think through the problem, and that designs it out, and you'd be surprised about what kind of things you come across that you didn't think about if you just dove into the code. Because if you do it that way, the other thing you're going to have a problem with is just you're going to write the same code in multiple places. So if you did this ahead of time, you would structure your code to where, hey, I need like a clear method that resets the game board. So rather than writing this same code in 10 different places, you could just create ahead of time one method that says clear. And same thing in this tic-tac-toe class. You're thinking through these methods and you're thinking about how to solve them. And so you're not going to duplicate code and you're not going to come in here and struggle with how to solve the problem because maybe even just wrote some comments within this method. So I promise you, if you do this ahead of time, you'll be in such better shape because 10 minutes, 20 minutes at the beginning, even designing it out on paper and just thinking through the problem is going to save you so many headaches along the road. So one kind of a history lesson where that comes from is the use of go-to statements. I've talked about how I've maintained all kinds of old programs in Fortran or Ada, and something like Fortran that uses go-to statements, it's just so much more likely that they're going to have bugs because it's hard to figure out the actual path of your program because it could literally just jump around anywhere. Where now within our object-oriented programming, that's not true. We're actually breaking things out into objects. It's a top-down approach, and so the way we structure it, it's less likely to have bugs than they used to. So now I'm going to go ahead and we'll go ahead and get rid of some of this code to clean it up so we can write some examples now. So today we're going to talk about control structures and just some very basic control structures. So the first thing I want to look at is just some if-else statements. So let's go ahead and create, a Boolean variable. We create some sort of Boolean variable. The user passes this in. We do some testing with it. And so with our if statement, we're going to do some sort of, so we say is true equals true. We can see our IntelliSense starts typing with us. And so this hasn't been assigned a value, so it's not happy. And so there we go. We now have an if statement that says if this particular variable is true, execute this code, else execute this code. I don't think this is anything new you haven't seen before in your other classes, but we just need to go over the C# syntax on how exactly to do this. The other thing I want to show you this is really helpful is if I start typing if, you can see how the if statement actually pops up here, and there's something called a code snippet. So there's all kinds of code snippets, and you can actually manage them and create them yourselves, but when you see these code snippets, all you have to do is press tab tab. So I press tab tab and you can see it actually puts this snippet of code in here for me. So if, for instance, you want to do a for statement and you forget the exact syntax, you do for tab tab and it just pops up with this little snippet of code. So again, there's all kinds of code snippets that you can actually write your own or you can edit it through the editor. So let's go ahead and take a look now at a program from the book. And so this particular example is figure 5.6 from our book, and it's talking about a gradebook class. And so we can see we've got this property. Again, don't worry about the syntax here. This is just basically an attribute. This is all this is. So there's just we have a string attribute called course name. Here's the constructor. You can see we pass in the course name so that when we actually instantiate this class, like we do over here, we can see we instantiate gradebook, and here's the name of the book that we're passing in. So this is our constructor right here. It's probably a little easier to read if I put it on one line of code. So we're calling this constructor, and that's where we actually set the course name. We have a method inside here called display message that we're just simply writing out to the console the name of the course. Then we have a public method in our class called determine class average. You can see we've got some integers here. We're initializing them. And now we're going to look at a while statement. So we use a while statement where we're going to have this sort of, processing test that we do first that says how many times, keep going through these loops while this statement is true. So in this case, we're going to loop through 10 times. So we can see grade counter is equal to 1, and because it's less than or equal to 10, we're going to go through it 10 times. We're going to write out enter your grade. We're going to notice that then we read in the grade from the console, and then we just can keep adding this up. We figure out the grade counter, how many grades we've entered, or increment the grade counter by 1, and then we're going to come down here and we're actually going to then figure out the average. So let's walk through here and let's take a look at some of the actual problems with this program. So we're going to hit this particular statement, and we can see we're going to step in here. So now we're going to write out enter your grade, and now we're going to go back to the console to get that grade. Now what's going to happen though if I enter a letter here? It's going to crash. So as we talked about before, you always want to use that int32.tryparse. Do not use convert.int32 where there is a possibility of an exception being thrown. So we'll enter in the number 6, press enter. We can see we have our total plus our grade, which they just entered. So now you can see we're just going to keep incrementing our total. And then our grade counter is 1. So now our grade counter is 2. So we can see it comes back up. This is still going to be true. And we're going to continue doing this 10 times. Then we're going to come down to this statement. So let's go ahead and enter in some grades here. So 3, just randomly put in some grades. So now we come down here, and we can see our total was 138. We're going to divide that by 10 so we can get the total average. So let's take a look at our average. Now you'll notice our average is actually an integer, and our other variables are all integers. So is this really what we're going to want here? We're actually dividing an integer by an integer. So remember, that's actually going to get us integer division. So we could even see this within our watch window. If we come down here and paste this in, you can see we actually get 13, which is not what we want. Because what we're actually dividing by is 10, and our total is 138. So we're actually going to want decimal places to be included with this. So if this was something like 139, and we then calculated the average, it's not going to give us that decimal points like we're looking to because we're doing integer division. So let's take a look at the next program. We'll kind of solve this integer division issue. So here's that same one with our gradebook. We come down here, we have our while statement, except we're going to do something a teeny bit different. We're adding a little bit another level of complexity with this program where we're going to continually allow the user to add more and more grades until they press a -1 to quit. So here's our while loop, and they've changed it up a little bit, and you can see as long as you haven't inputted a -1, it's just going to continue looping over and over and over again and just keep saying, hey, enter the grade, enter the grade. And then finally, when it's done, now we know how many grades they've inputted. We have the total, and you'll notice that if I highlight this, we can see total is still an integer, grade counter is an integer, however our average is now a double. Again, I can right click on this, go to definition, and we can see it up here at the top. So we're really wanting an average. Well, the problem is, remember, before we had code that looked like this. So we're dividing an integer by an integer, and that gave us integer division. What we really want to have happen is get a decimal when we divide this so we can get the correct average. So one way we can do this, we could have made, it makes sense to have these integers, but so now what we can do, if these were doubles, it would already be done. But what we can do is we can cast just one of these values. So if we cast this up to a double, behind the scenes it'll actually go ahead and cast this to a double for us and then do the correct calculations. So integer division will no longer happen here. So this is where we explicitly cast this to a double. And we could also do convert.toDouble, and this would be exactly the same in this instance. So let's go ahead and take a look at another program now from the book. So this next class is going to be dealing with how you increment and decrement. So we can see that we have this plus plus operator, which is the post decrement, and then the plus plus where this is the the pre-increment. And so what this is going to do is this is going to assign this to 5, print out 5, this prints out 5, adds 1, prints out 6. We're down here, this is going to set it to 5, increment it, then print it, so this displays 6 and then displays 6 again. So you just need to know the difference between pre and post, and it's exactly the same if we do minus and minus. That's all there is to it. And generally we'll see this in 4 statements in the next lecture. So now let's go ahead and write some sample code so that we can just kind of get familiar with these if statements again. So what we've done, we've got this UI where the user can just enter in some value, and we're going to print out some things to this rich text box. So the first thing we want to do is we want to extract the number from the text box. Now sure enough, we're doing this incorrectly. So what did we really want to do here? Let's go ahead and just copy and paste this code. And we say, okay, we did not want to use int32. What we really wanted, we want to use convert. What we want to use is int32.tryparse. And then we can pass in the string. Then you'll notice we have to use the out keyword. Don't forget that. And then we can see, I result. Oops. It auto-completed that for me. Now I just made up this variable here. So you can see it's telling me, hey, I don't know what in the world. If I want to, I can actually go ahead and generate this, and I can press this, and you can see it actually created it for me up here. But now this is a class level variable. So maybe that's not really what I wanted. Again, I probably should have just typed it in, but I want to show you that little autocomplete. And so now I type in iResult here. And so now what this is going to do is we can now do an if statement. So if this is true, then we can go ahead and set iNumber. Well, then iNumber, will actually be this already. And so now result will be set to that value. So we can either use result, or we could do something like this, just so we don't have to change any code that we've already written. And then what we'd probably do is we'd have an else statement now to give the user, a message box that pops up that says, hey, please enter the correct value. For our case, we're just doing some demonstration purposes. So it's going to pull in the value, return it through iResult, and we'll set it to our number, so we can go ahead and just keep using number. So let's go ahead and get rid of that. So now let's write some if-else statements just to work with our number here. So we can say if iNumber, is greater than 5. So if it's greater than 5, we happen to have a label on here called LBL1. Let's set its text property, and we can now tell the user number is greater than 5. And now we can see here we've got this use of unassigned local variable. So what that's just saying is that there's a possibility that we've never assigned this. So we can just go up here, set that to 0, and we can see it's nice and happy. So there's also a possibility of what? That else if iNumber, is less than 5. So we'll do the same thing with our label. Say less. Now there's only one other possibility, which is that it's equal to 5. So we can say this, now we can say equal. So now we've got our if-else statements on testing the number, giving the user some output. Very simple, straightforward. So now let's talk about the while loop. So here we've got this counter, and we're going to go ahead and just type in our while loop. So if we want this to go till the while condition is false, we can say iCounter is less than 10, for instance. And so you'll notice iCounter is 0, and since we're saying less than, how many times is this going to go through? It's going to go through 10 times, because this is actually going to go 0 through 9, which is going to give us 10. Or we could have started this at 1 and done less than or equal to to give us 10 iterations. And then from there, we're going to use our rich text box, not a regular text box, but a rich text box. We're going to output our counter. Now this is an integer, so we have to use our toString on the end of it here so that it can display that. And then we're actually going to want to print out a new line character. So there's this environment variable here that we can access. So if I say environment dot, you can see it gives me all kinds of things about the current environment. Like I can get the current directory. So you can see where the current working directory is, exit codes, all kinds of machine name, what the OS version is. So the current environment that I'm working in, what's some information about it. And the main thing that I use for this is what's called the new line character. And what this does is this gives you whatever the new line string is that is defined for the current environment you're working in, because it can be slightly different. It's not, sometimes it's like \n/r for carriage return and new line character combined. And so that way you don't have to worry about what it actually is. Just do environment.newline and that'll print a new line character in your rich text box. Then we're just going to go ahead and just showing you how we can increment the variable here, and then just showing you some other ways that we can kind of do the same thing. We could actually just fully write it out. We can actually do minus equals, or here we go, we're doing the minus minus or plus plus. So just showing you various ways that we can do increment and decrement.